let's prove that the derivative of secant z is equivalent to the product of secant z and tangent z for this video. So we are going to use here the rules of differentiating a function, no longer using the definition because it would take us a lot of time. Just be guided that our function here is actually secant z, and to identify the proper rule to be used is the identification of secant z, which is equivalent to the ratio of 1 and cosine z. With that, it's a rational expression, and hence we can use here the rule of differentiating the quotient, because once we have here k of x, which can be expressed as m of x over n of x, where n of x is not equal to 0, its first derivative is equivalent to the denominator times the derivative of the numerator minus your numerator times the derivative of your denominator all over the square of your denominator. Okay, so this would be our denominator, 1 is our numerator, so allow us to use this rule in solving for this or proving this identity. Its first derivative will now follow with cosine z times the derivative of 1 is 0 minus 1 times the derivative, okay, the derivative of cosine z is actually negative of sine z. So times negative of sine z all over cosine z. Okay? Squared, by the way, I forgot. The square of cosine z. Now, if we're going to continue with this, cosine z times 0 is 0. The negative times negative is plus sine z all over the square of your cosine z. Allow me to express that in this manner, okay? Not squaring that in the meantime, because as I move down here, I can write this as sine z over the square of cosine z. Since there are two cosine z's in the denominator, I can rewrite it in this manner, sine z over cosine z times cosine z, right? Now, take that our numerator is a product of 1 earlier in sine z, or there is a numerical coefficient of 1 here. So I can break it into two different rational expressions, just like if I have here, say for example, how could I express it this manner? Let's say 12 over, let's say, 16. Just an example, okay? We know that 12 is actually 3 times 4, and our 16 is 4 times 4. So I could have here 3/4 times 4 over 4, right? Okay. In this case, we have 1 here. So I can have here 1 over cosine z times sine z over cosine z. What was 1 over cosine z? That is actually secant z, and sine z over cosine z is another trigonometric function identified as tangent z. This is the proof that the derivative of secant z is equivalent to the product of secant z and tangent z, indicated by this process using the rule on differentiating quotient. Okay? So this is the proof for that, and if you see later on secant z and you're asked to find a derivative, use this equivalent value. Thank you very much for watching.